Hello, I am Erdem from Uvision. In this video we will learn op-amps or operational amplifiers. It's another handy circuit component and it has 5 terminals. First terminal is inverting input terminal and mostly denoted as V sub minus. Second terminal is non-inverting input terminal and we denote it by V sub plus. Next two terminals are supply voltage terminals. You set maximum and minimum voltages that op-amp outputs by these two terminals, and we mostly denote them by E plus or E minus. Most of the time they are given as equal, of course with a minus sign difference. For instance, if this is plus 12, this is minus 12, or if this is plus 15, that's minus 15. But for general cases, we denote this terminal by E sub plus, we denote this terminal by E sub minus, and a last terminal is the output terminal. All right, how do we model this op-amp in real life? This is an equivalent model of the op-amp. There are many circuit components in an op-amp, but for simplicity we can model an op-amp like this. There's a term called VD, which is defined as voltage difference between non-inverting and inverting terminals, and V plus minus V minus is the mathematical interpretation. We can supply V out by a dependent voltage source, and its value is dependent on VD and a constant that is called open loop gain. You take this difference and you multiply it with a constant. You send it through output with a resistor. We will talk about these. Our input current, we will talk about this input resistance, output resistance, and open loop gain, etc. Op-amp operates on 3 regions, as I told you. By these terminals, you are setting maximum and minimum limits of op-amp can output, and there are 3 regions op-amp operates on. First region is plus saturation region. Op-amp is in plus saturation if output voltage is equal to E plus. Op-amp is called in linear region if output voltage is between E plus and E minus, and op-amp is called in minus saturation if output is equal to E minus. Now let's talk about the values of these A, V, D, R0, Ri. A is called open loop gain, and that value is between, most of the time in real life, 10 to the 5th and 10 to the 8th. But in ideal questions, we are assuming that A is equal to infinity. Alright? The input resistance, that is this resistance, and VD is defined across that resistance actually. In real life, that resistance is between 10 to the 5th and 10 to the 13th. But in ideal questions, we are assuming that is infinity. So, in ideal questions, there is no resistance between plus terminal and minus terminal of the op-amp, that they are directly like this. V minus, V plus. There is no resistance in ideal questions. The third value is output resistance. In real life, that's usually between 10 ohms and 100 ohms. But in ideal questions, that is 0 volts. And VCC is another term for E plus and E minus. VCC is usually between 5 and 24 volts. This C comes from transistor. That stands for collector. In history, this term is firstly used for transistor. So that C comes from collector of the transistor. So This VSAT is usually between 5 and 24 volts. So E minus is between -5 and -24 volts. Let's look at ideal case of the op-amp. This is how you interpret ideal op-amp in questions. And this is your inverting, this is your non-inverting terminals. This is your output. As I told you, we mostly don't draw these saturation inputs because schematic looks messy in that way. There is no input current in an op-amp. So in every ideal op-amp question, you will assume that there is no current entering through inverting and non-inverting inputs. That's an important property of ideal op-amp. But this output current does not necessarily have to be 0 amps. It could be any value, doesn't matter. Now, let's talk about regions of the op-amp again, but for this time ideal op-amp. If op-amp is in linear region, voltage of the non-inverting terminal is equal to voltage of the inverting terminal. And this is a very important property in analyzing op-amps, so please note this down. If you are analyzing an ideal op-amp and that is in linear region, V plus is equal to V minus, and V out is in between plus saturation and minus saturation. If op-amp is in plus saturation region, and if it is an ideal one, voltage of the positive terminal or non-inverting terminal is bigger than voltage of the negative terminal or inverting terminal. And output voltage is equal to plus saturation voltage, which is ES. When op-amp is in minus saturation or negative saturation region, and if your op-amp is ideal, voltage of the non-inverting terminal is less than voltage of the inverting terminal, and output voltage is equal to minus saturation voltage. That's all for this video I want to talk about on op-amps. Thanks for watching.